In this video, we're going to be finding the exact value of an expression involving inverse trigonometric functions. So the first one, I want to find the exact value of sine of arctangent of 1/2. Okay? So first thing I want to do with this, I want to recall that trig gives me the ratio sides of a right triangle, okay, and that trig inverse, what does that tell me? That tells me the angle theta. So I'm going to deal with the trig inverse inside here, and I'm going to call this theta. Theta is equal to the arctangent of 1/2. Now, this defines a particular triangle, okay? So what particular triangle does this define? Well, if I tangent both sides, I get the tangent of theta equals 1/2. I know that tangent is opposite over adjacent, okay? Tangent of 1/2. So let's draw a triangle. Now, opposite over adjacent. Now, these are either both positive or both negative. Okay, so either it's in Q1 or Q3. However, what do we know about theta? Theta is between negative pi over 2 and pi over 2. So the only options you can have are going up to pi over 2 or down to negative pi over 2. So it could only be in these quadrants. So the only option we really have is in Q1, okay? So Q3 is out of the picture here for us. So let's draw our triangle. So what is it? Opposite rise over run. So y over x, okay? So I rise 1, I run 2. So my dot is somewhere over here. So I'm going to draw a triangle. And so I'm going to rise 1, run 2. So let me draw this triangle a little bit bigger over here, blow it up. So it's a side with 2 and 1, and this is my angle theta. Okay? Now what do I want? Theta is equal to arctangent, so I'm looking for the sine of theta. The sine of theta, some old hippie, opposite over hypotenuse. So what do I need? I need to know what the hypotenuse is. How do I do that? Pythagorean theorem. A squared plus b squared equals c squared. So what is the c here? That's my radius squared, right? That's my r. So what is that going to be? That's 4 plus 1 equals r squared. So that's 5 equals r squared. And when I take the square root, I get a square root 5 here, okay, for my r. Now, the sine of theta is opposite over hypotenuse. So that's equal to 1 over the square root of 5. 1 over square root of 5, if I multiply top and bottom by square root 5, I get square root 5 over 5. So my answer, sine of arctangent of 1/2 is equal to the square root of 5 divided by 5. Okay? So the thing to remember here may help you out. Sine theta, y over r. Cosine theta, this is x over r. Tangent theta, this is y over x. Cosecant theta, this is 1 over sine theta. Secant theta, 1 over cosine theta. And then cotangent theta is 1 over tangent theta. So those are the reciprocal functions, okay? So literally you do the reciprocal instead of y over x, it's y over r, it's r over y. Okay? So let's run through with another example. Cosine of sine inverse of negative 1/3. Okay, so I'm going to let theta equal sine inverse of negative 1/3. I'm going to sine both sides and I get sine theta equals negative 1/3. Now, sine inverse is only defined for theta between negative pi over 2 and pi over 2. Okay, negative pi over 2 and pi over 2. So what quadrant is that? That's either quad 1 or quad 4. All right, so any of those values in here. So if sine theta is negative, well, what do I know? All students take calculus. Everything's positive in the first quadrant. Sine is positive in the second. Sine is negative in the third, and sine is negative in the fourth. So if I want a negative sign, it looks like I'm going to have to be down here in quad 4. So that's how I'm going to draw my triangle. So I draw my triangle down here. Now sine, what is that equal to? That's y over r, okay? Now r is your distance from the origin to the dot, so that can't be negative, so the y has to be the negative here. So what is that? That's negative 1 down, and then my r is 3. So now, what do I need to find? Well, what I want to find is the cosine of theta. Okay, so this is my angle theta. Okay, so that's my theta here. Now, how am I going to do this? I need to know what this side here is, right? Cosine of theta, x over r. So use Pythagorean theorem, x squared plus negative 1 squared equals 3 squared. So x squared plus 1 equals 9. Minus 1, I get x squared equals 8. So when I square root this, what's going to happen? Square root, well, excuse me. I get x equals, well, square root of 8. 8 breaks down to 4 times 2. The square root of 4 is 2, so that comes out. But this last 2 has to stay inside the radical. Okay, so this side here becomes 2 square root 2. Right? So this is going to be what? This is going to be x over r, and x here is 2 square root 2 over 3. And that is my answer. The cosine of sine inverse negative 1/3 is equal to 2 square root 2 over 3. 2 square root 2 over 3 there. Okay, so determining what quadrant we're going to be in is key. Otherwise, you don't know, was it supposed to be positive, was it supposed to be negative, and so on. Okay? Because when you take square roots, you get plus or minus, right? So that's determined. We're figuring out if it's the positive or negative based off of where we're falling here. Okay. So just to recap, quad 1, everything's positive. Quad 2, only sine and the reciprocal cosecant are positive. Quad 3, only tangent and the reciprocal cotangent are positive. Quad 4, only cosine and the reciprocal secant are positive there. Okay. Another trick that helps you out so you remember where the inverse functions are defined. Cosine inverse goes between 0 and pi. Okay? Sine inverse goes between negative pi over 2 to pi over 2. Okay, so it's here to here. And then tangent's kind of off on the side here. Tangent, instead of including, it doesn't include the actual terminal y-axis here. Okay, so it's just the open interval between negative pi over 2 and pi over 2 for my inverse functions. Okay, so maybe that helps you memorize it, maybe it doesn't, but if it doesn't, you figure out a trick that helps you learn it. Okay. The all students take calculus is all students take calculus. That kind of helps a little bit. Everything is positive. All the trig functions are. Students, sine and cosecant. Take, t, tangent, cotangent, c, cosine and secant. Those are the positive ones for that quadrant. All right. So the last one here that we're going to deal with, we're going to have the tangent inverse. Let's do the tangent of cosine inverse of negative 1/3. Okay. So same thing in here. I'm going to set this equal to theta because trig inverse gets me angles. And I'm going to run through my properties. Cosine theta is equal to negative 1/3. Now, cosine theta, okay, inverse is only defined from 0 to pi. So negative 1/3, cosine is your x value, so it's negative. It's all are positive here, but it's negative over here. So I know that I'm going to be going this way. Okay, so now I just got to figure out what it is. Cosine is x over r, right? R can't be negative, so the x has to be the negative. So negative 1 divided by 3. So I go over negative 1, and then my dot goes out to 3. So I don't know what this value is, but I know that this over here is my negative 1. Okay, so I've got my right triangle. And so what I'm looking for is my theta. Okay, I need to know what this angle is here because what I really want is that I want the tangent of what? The tangent of theta. So when I look at this triangle, so I'm drawing it a little bit bigger here. This is my theta. I know that's negative 1. I don't know what that is. I'll call it y. And I know that that's 3. So y squared plus negative 1 squared equals 3 squared. So it's y squared plus 1 equals 9. This looks familiar. Minus 1. I get y squared equals 8. Okay. When I square root, I get y equals, well, what's the square root of 8? That's 2 square root 2. Okay. Now, why do I take the positive one? Well, when we're in this quadrant, y quad 2 is greater than 0. It's positive, okay? So what is this equal to? This is y over x. So that's 2 square root 2 over negative 1. So 2 square root 2 right here. Opposite divided by adjacent. Okay? So what does that get me? That tells me that the tangent of what? Cosine inverse of negative 1/3, which is what theta equals, right? That is equal to negative 2 square root 2. Okay? So the trick here is first setting this inside equal to theta and rewriting it. Then you determine which quadrant am I in. Okay, so I use my trick. Okay, I see cosine inverse is only for that first and second quadrant. And then everything's positive in the first, but I want it to equal a negative number, so that means I have to be over here. Okay, so I draw my triangle, and once I draw my triangle, then I look to see what the new trig function is. So it's tangent theta, and I do opposite over adjacent. And then I've got my answer right there drawn from the triangle.